Then let's start. Right. Well, good morning, ladies and gentlemen. Good morning, everybody. Welcome to this webinar, which is sponsored by the European Open Science Cloud, the EOSC-Nordic Baltic project, to be precise. My name is Bert Meerman. I'm from the GoFair Foundation, and it is really my pleasure to be your host for the next 2 hours or so. As you may know, we have defined an EOSC project where we have started to evaluate the fairness of metadata and data published by the different repositories in the Nordic and in the Baltic countries. Let me start by showing you a slide on FAIR. The term FAIR is defined here as findable, accessible, interoperable, and reusable, and relates to 15 FAIR principles that data and metadata should adhere to. And not only for the human eye, but mainly for machines. Let me repeat that, not only for human eyes, but mainly for machines. The machine should be capable to find, access, interpret, and reuse the data and metadata of a repository. FAIR is all about findability, machine actionability of data and metadata. Let's keep that in mind. Now, I'm not going into great detail here, but if some of you have, or if some of you are not familiar with the FAIR principles, please take time to study this in more detail. It's an excellent model to increase the interoperability of research data, but also energy data, asset management data, financial data, COVID patient data, and all kinds of other domains. Allow me also to emphasize that FAIR is not the same as open and free. A data set can be offered in the market under predefined conditions at a fee or a subscription and be completely fair. And so making data fair does not necessarily mean that you have to give all your data away for free. Right, back to the assessment process. We organized last year in April, and some of you were on these calls, a hackathon event. And we evaluated a number of repositories on the basis of their machine findability on the internet. And for the evaluations, we used software programs that could quantify the adherence to the FAIR principles and could automatically perform these evaluations using the latest FAIR maturity evaluation software. How does that work? A FAIR maturity evaluator takes as input a global unique persistent resolvable identifier and explores the provided machine actionable metadata within the repository's landing page, normally, typically. If the software finds the ID, it can then evaluate against the FAIR principles and calculate a FAIR score for each of the letters F, A, I, and R. If you fail on a particular test, we can provide recommendations how to improve the fairness. This is in short how the program works. During the first exercise, we discovered that some repositories could not be properly evaluated due to a lack of a proper ID. We therefore hosted a webinar last November on, let's say, being findable through a persistent resolvable ID. And this inspired many of you to take action and to assure that most of you now have a proper ID. So that is a good result, I would say. The exercises done in April and in November were a success insofar that a large number of repositories were evaluated, and we were able to provide a number of recommendations to repositories who wanted to improve their fairness score. However, we also noted that a large percentage did not pass the test for principle F, F3. F3 is about making a proper machine recognizable split between the data and the metadata. The principals want to see that the metadata points to the data, and in return, the data points to the metadata. Once this is the case, the evaluator tests for principle F3 will pass. And this is exactly, it's exactly this principle F3 that we want to discuss in this webinar. I hope it's clear what we are trying to achieve here. Let's take a look at the agenda. We have this morning a number of distinguished speakers. We start with Andreas Janssen from NEIC, giving us an overview of the assessment results in the Nordic-Baltic project. After that, we have Erik Schultes from GoFair, explaining the importance and the relevance of Principle F3, giving us a wider picture and some guidance. We then have a small break. And after the break, we have Robert Huber from the University of Bremen, talking about machine-friendly implementation and showing us the Fuji evaluator, some of these results. Then we have Philip Gonzet from Dataverse with a practical approach, talking about file level identification support in Dataverse. And then we have a Q&A session guided by Josephine Nordling from CSC. And I will then close with a few remarks and a call to action. So before we start with the next speaker, a few house rules. Feel free to ask questions via the chat. We will pile up all the questions in the chat and address them at the Q&A session in the second hour. Be also reminded that this session is recorded and that the slides are saved on the registration page. And this gives you the opportunity to also check the content at a later stage. So thanks very much for being with us this morning. And without further ado, I would now like to pass over to the next speaker, which is Andreas Janssen. Thank you very much.
Thank you, Bert. Yes, welcome everyone. I hope you can see one single slide. Yes, sorry for those of you who have heard this before. We are now about close to halfway in the EOSC-Nordic project, one of the 5 or so infra EOSC 5B regional implementation projects. And I will speak today about the work that has been done in work package 4 in the EOSC-Nordic project. So the project itself consists of 6 work packages. The main ones being policies, legal issues, and sustainability. Work package 2, support of EOSC service providers, and also readiness for service provisioning through the EOSC. Work package 4, fair data, and work package 5, open research demonstrators. So the team consists of about 20 members from about 14 different partners. So we have tried to cover the entire Nordic and Baltic region with the members of the team, and in addition, Bert from Holland and the GoFair Foundation, making 21 participants. So, as Bert mentioned, the core essence of our work when it comes to assessing fairness relies on this machine actionability aspect. So we believe that this is a fundamental requirement, and therefore a web page such as the one we're seeing an example of here which is presented to humans for human consumption is not sufficient in order to become fair for the machines. So in order to have a look at that, these fair assessment tools, they go under the hood and look for basically harvesting any metadata that can be extracted from within the web page or the landing page, as the dataset typically is referred to, and any references therein. So one of the models or the concepts that we are hoping to convince the various research repositories, data repositories to eventually adopt is one where you have a global unique identifier or persistent identifier, which points and resolves to a digital object, the data set record, and that this data set consists of a pointer or another link to the object, the data itself, and also separately to the metadata, and that that the metadata also refers back to this main digital object. So this is part of the FAIR digital object concept. But FAIR is quite diverse. Depending on who you ask, you probably get very different answers of what they interpret or understand by FAIR. But from the Wilkinson publication 2016, there are a number of issues that can be extracted from this paper, and FAIR requires work on many different levels, and it also requires time, and it's unlikely that we will see. I mean, there's no point to talk about data sets that are fully fair. This is a continuous evolution towards something which is fairer. So to achieve this fairness, we believe one very important concept is, or principle is, to involve competent support staff. So data stewards play an important role in assisting researchers and data managers to make data fair according to these FAIR principles. So there are already a few examples. This one from the technical university for life sciences in Holland, DTL, where they have created a FAIR data stewardship program, and also worked this into the curriculum of and they're teaching this as part of the university education, and also training and hiring data stewards to assist the researchers on campus to make data fair. So what we have done in EOSC-Nordic is to survey the Nordic region for repositories, research or data repositories which have relevance for research, and we came up with about 100 such repositories. And we want to evaluate those repositories with, we started off with the Wilkinson tool from 2019. This is also published, and later moved on to the tool which is described in Devarju in 2020, also known as the Fuji Tool. So in order to do these assessments, we require a persistent identifier, or at least a global unique identifier. So for instance, a URL, which points directly to this digital object or the data set itself. So what we did is then, for each of these 100 repositories, we selected about 10 random data sets from each of these repositories. And for those that supported persistent identifiers, we also duplicated the same data sets using the persistent identifier. So we came up with more than 1,000 data sets. And the goal here is really, with this assessment, is to be able to guide communities to provide these assessments as an input to the communities that are behind each of these repositories, in order to allow them to improve and to give them also advice on how to improve their score, or how the aspects of fairness that the assessment tool output tells us. So this event here is one such step in this process. So lately we are primarily using the Fuji Tool, which we will hear more from Robert after the break. And this takes as input a global unique identifier or a persistent identifier, and it will then look for about 16 metrics, I believe it is, and test each of these systematically. So in order to streamline this, we implemented we basically collect all these global unique identifiers in a Google Sheet, and then have set up a script to process running this evaluator in the background for each of those. And then we do this also regularly every 2 or 3 months. So this is the output of that process. We have now about 75 evaluated repositories, for which we have calculated an average score based on typically 10 to 20 data sets from that particular repository. So if we look at the entire sample, then as Bert also mentioned, there is a uncomfortably large fraction, 24% of these 100 repositories that could not be evaluated because they do not provide a global unique identifier, a pointer to each specific data set. So that, as I mentioned, is a premise to do these assessments. But for the 75 remaining repositories, this was possible, and these are the average FAIR scores for each repository. And not surprisingly, this shows that the 40% score in quite low, and there is only about a third which scores, I would say, intermediately to good. So this is why we are doing these assessments, trying to help communities and repositories to improve their fairness. Looking at the same results, but here separated into the findability metric, accessibility, interoperability, and reusability metric, we see that the results are, for those that do not, for those that pass over the sort of the minimum or a 0, the results scatter quite well across the band, at least for most of these metrics. So this is and this is also developing. So that's why we are doing this regularly, re-evaluating or assessing all the data sets in order to allow give us insight how this evolves over time. So if we look then at some of the specific FAIR principle related tests that are conducted in this Fuji tool, we find that, for instance, licensing is not very common among the 1,000 or so data sets. So just about less than 20% have a license declared, and even less than that pass the metric F3, which is the focus of today's event. So this is that the data element is uniquely identified in the metadata. And this is something that definitely can be improved, and which we hope this will do so following these events. Related somewhat to this is also the metric R1, or the test, which tests for whether the content, the data content is sort of declared in format and size, etc. Finally, we have also started to study to look at what are the typical for instance, PIDs that are used. So we see that in the two left columns here, there are about 2 or 3 times as many DOIs used among these data sets than handle. And and for the majority, there are no persistent identifiers at all. In the green box here, we see a comparison of the use of different or support for different types of metadata standards, which will be a topic for a future FAIRification event such as this. And finally, we also had a look at how typical it is to declare the data set or the digital object as a data set. And this is only happening in about 1/3 of the data sets. And also whether the access rights and restrictions are declared. So a lot of information can be extracted from these assessments, and that is what we are currently doing and continuing to do for the remainder of the EOS-Nordic project. And at the moment, these 75 repositories have an average score of 22%. So there is quite a lot of way to go, and so a lot of potential to improve. And if we look at only those repositories that are running on well-known platforms like Dataverse, for instance, we see that the average increases from 22 to 38%. And similarly, for certified repositories, they have a somewhat higher average at 29%. Okay, so that was my presentation. I'll hand over to Bert again. Thank you.
Yes, thank you very much. That is very useful, gives us a good insight in what is happening. I would now like to move over to Erik, because I think Erik is our next speaker.
Great, excuse me. Thank you, Andreas, and thank you, Bert. Good morning, everybody. I'm sharing my screen right now, so I hope you see the title slide, and I hope it's visible to you. I'm going to share my slides today through the non-presentation mode. Tends to work better with Keynote that way. So good morning. My name is Erik Schultes, and until quite recently, I was at the GoFair International Support and Coordination Office, and now I'm working at Leiden University, but also at the GoFair Foundation. So a colleague of Bert. And my background, just so you know, is in biomedical research, and I was doing RNA biochemistry and evolutionary biology. Those interests became more data intensive. And so over time, I migrated more and more into the data space, into FAIR and its related activities. So I'm a researcher by training, and the last few years have been really full-time with FAIR and GoFair. And I am going to acknowledge at the top here that I had some pretty extensive conversations with Nicola and Mark in preparing for this presentation today. We were examining some data sets, and some of the things I show you are really the result of the conversations I had with these guys. And I want to start again, so maybe just sort of going back to the beginning once again, where Andreas and Bert also began. You know, the FAIR principles were first, I would say, officially published or published in a peer-reviewed context in 2016 in Nature Scientific Data. And as Bert had mentioned already, you know, the definition of FAIR, and I'm lifting this definition directly from the paper, it's a quote, but it's data and also services that are FAIR for machines, you know, but if for machines and certainly also for people or on behalf of people. So there was a real sense from the beginning with the FAIR principles that we were trying to look for kind of high-level directives or requirements that would allow the machine to more and more do FAIR in an automated way. And so the diagram at the bottom here, this boat propeller, is one way to kind of encapsulate this. You know, there's data, there's applications and tools, and there's raw compute services like CPU time or storage. And these three elements are envisioned to more and more interact in an autonomous way, relieving the data scientist or the human user in general of a lot of burdensome tasks associated with data munging and just kind of the FAIR thing. So activities that are highly redundant in data science should more and more become something that's machine actionable. But to do that, you know, certain things have to happen first. And this was the FAIR principles as they were published in the paper originally. And you've all seen this many times by now. I like to highlight that metadata is everywhere in the FAIR principles. And of course, today we wanted to focus on F3, which is asking that your metadata clearly and explicitly include an identifier to the data set that it describes. And by identifier, and I think we really mean here the globally unique, persistent, resolvable identifier. And by saying clearly and explicitly here, it's really referring to that there is a rich and qualified reference from the metadata to the data set itself. So that if the machine, if a computational agent were reviewing this metadata, it would actually be able to automatically discover the link to the data set itself. And this happens a lot for the human anyways. You know, in ordinary, if you're looking for research articles online, you get to the landing page of the article, there's lots of links there, and you can see where the PDF button is, and you can click it, and you can automatically get to the data. But because it's useful for the human, it doesn't necessarily mean that it's also something that the machine can do. Certain things have to be in place to enable that capability. And what I just want to take a few slides in to explore what that really means. And I'm going to touch upon F1, F4, A2, I1, and I3 in the rest of the talk. So you can see that F3 is actually quite fundamental to FAIR. It's like, besides F1, where we just assign identifiers, F3 may be, you know, the most fundamental principle here. And it seems so simple and obvious. I think many times people are surprised that this isn't already the case. But surprisingly, as Andreas showed us, you know, it's not. but I think a lot of interesting solutions are on the horizon, and you'll see them presented in the next couple hours. But let's start by examining a case where data and metadata are actually combined. They're not split. And there's actually a whole philosophy behind this called self-documenting data. And there's sometimes very good reasons to do this. And especially if you have standards that are widely adopted, this can be a very powerful combination, actually embedding your metadata in the data set itself. There's a file format out there called NetCDF. It's very popular in ocean and marine sciences. I think maybe earth sciences in general. Here's an example of a NetCDF file. It's about 20 megabytes. It's recording 5 Hertz measurements for many different variables. So there ends up being about 1.5 million samples in here. And if you look inside that file, you will see the embedded metadata. Here's kind of a header for that. And then here's a bunch of metadata associated with each and every variable. So very richly described, which is certainly in compliance with other FAIR principles. But this data is definitely embedded in a single file. This makes it very powerful in that there are tools that can automatically then parse these files and process them. And so there's visualization tools, plotting tools that make it very straightforward to just take these files and do operations on them, which is very nice. So then why in the world do we need to really think about decoupling data and metadata? And then go through the trouble of making sure that there's a permalink between them. Well, here's some reasons. And I've tried to annotate them a little bit with the FAIR principles again. But certainly, in many cases, metadata are much smaller just in their size and their bulkiness compared to the data sets themselves. So for example, in like NetCDF files, you may have kilobytes of metadata, and you might have even gigabytes or terabytes of data set associated with it. And if you wanted to investigate what those data sets contain or something about them, rather than downloading or somehow trying to access a gigabyte or a terabyte of data, why not just be able to download the metadata itself and examine that? So there's a very useful kind of just performance-based issue to separate data and metadata. There's a cost of maintaining metadata that would then be lower. And this is actually getting us close to principle A2, which is asking that metadata persist even if the data set is no longer there. So there's just an ease of curating that metadata and making sure that it's around. And then there's a bunch of issues that arise, if you separate data and metadata. There's a bunch of interesting doors that open up for potential standardization. And I think this is really key for FAIR. So on the one hand, we can begin to use the same technologies, the same infrastructures for implementing metadata and data access. So rather than every repository having its own unique way of doing this, we could begin to set up standards for these very common operations. The same applies to using a common knowledge representation language. So this would be I1. RDF is a way to go in whatever serialization you want to choose, for example. There's a chance now of converging onto metadata standards, or say templates, again, versus every repository doing something else. And this gets us to I3, which is asking for these qualified references that can tell the machine, hey, here's the link to the data set itself from the metadata to the data. So all of this can lead to increased machine actionability. At the metadata level, even though at the data set, all the wildly different types of data that there are out there, not all of those are easily made FAIR or made available to Sparkle queries, for example. But the metadata could be and should be. So you can separate them out and work with them separately. There's also kind of a separation of, let's say, policy level concerns. Researchers can often broadcast their data set through metadata even if that data set is somehow highly restricted in its access. So these are just some reasons why you might want to decouple it, but they're very fundamental to FAIR, very important for FAIR. So, maybe we see a lot of examples like this today, but here's just a couple of examples where, in fact, the metadata of some repositories, they actually do explicitly include that identifier to the data they describe, but still they fail at principle F3. It's not machine actionable. So here's example one. This is from Nicola. It's the Danish Technical University. And they have a repository at the university. I think it's running services from Figshare and from Datasite. And here's a link to a record. If you click on that, you get to this landing page. It's describing the data set. And at the bottom, there's a nice link to a download. And if you click on that link, you actually get to the data set, which is quite nice. But in the metadata that drives this, there's no machine actionable linkage between the data and the metadata. So it's there for the human, but not the machine. Here's another example, even more familiar maybe, that, I have an identifier F1, it's a DOI, and I'm using, a indexable, searchable resource like PubMed, and I can get to a research article here. And of course I can click on options here for the full text, call that the data. And there are in fact vocabularies that describe for a machine how to do this, but those vocabularies are not standard, and they're not, you could do this in an automated way, but you'd have to build a system that was specific to PubMed to do this. And wouldn't it be nice if there was a way that we could have an agreement on a more widely used standard for that? Very interestingly, Datasite, which of course is a pretty wonderful resource, is working on this, F3. At the moment, even Datasite does not maintain this F3 action. But here's a quote from an email that just arrived yesterday from Matthew Buys, the executive director. I asked him about the status of F3, and he said, feel free to tell everyone that we're going to be working on this implementation through their metadata working group, and they're going to be publishing their schema 4.4 coming up here, and they want to try and resolve this issue. So here's a case where Datasite, already a pretty well-established standard, will take a pretty important leap towards fairness by giving us an option for F3. And of course, because so many repositories are already using Datasite, this could be a pretty important development. Andreas evoked the idea of a fair digital object, which in my mind, one of the key functions of the fair digital object is in fact to make that connection between the data, that permanent connection between the data and the metadata, even though they're separated. In lieu of an agreed upon fair digital object standard, what we can work with already is something called the fair data point. And I think this is a nice practical example right now of what F3 looks like. The fair data point is a metadata publication platform, and in many ways contains functionality of a fair digital object. And this is a link to a reference implementation for this that was developed about the time the FAIR Principle paper came out in 2016. And there's been interesting developments and deployments of fair data points quite recently, especially driven by the COVID pandemic. But here's a little bit of insight into how the fair data point is implementing F3. So what I can say about the fair data point, it's using linked open data principles and World Wide Web principles to expose very richly semantic metadata so that machine agents and by the way, human agents can find this metadata and and then at a fine grain level of resolution, be able to locate the kinds of data sets that are important to the user. So the FAIR data point is a metadata publication platform, is using RDF and linked open data to do this. It follows the W3C standard data catalog, data catalog standard, DCAT. And if you know something about DCAT, it's basically this metadata structure, I think primarily for libraries and repositories, but it's basically 4 hierarchical layers. At the highest layer, you've got the repository, and within a repository, you can have one or many catalogs, data catalogs. Within a catalog, you can have many data sets. And within data sets, you can have what are called distributions. And distributions are really giving you the self-describing details, technical details of the data set itself. So for example, the size of the data set, the media type, the format, other things that let you know really about the how this data set is represented, so that, again, a machine would be able to come in and actually perform operations because it would recognize what it sees. And what I'm showing here in print that I'm sure you cannot totally see, but through my slides, you'll be able to check it out. But here's the 4 layers: the repository, catalog, data set, and distribution. And what I'm doing here is I'm just checking the boxes on metadata fields, like the title, the version, the description, the publisher, the language, the license, when it was issued, when it was modified, etc. So there's just a bunch of very standard ontologically based terms that describe your data. And this is how those terms have been reused at each layer. And so at the distribution layer here, you can see those terms at the bottom. There's links that describe for the machine, there's predicates here. How do you connect to the data set itself? And you can either download, or you can go to a live link, for example, with an API. I wanted to highlight, we also describe, the byte size here, so that, again, we've separated out the data and the metadata. And this allows you, the distribution metadata here, allow you to say, oh, I have a petabyte of data in this data set. I better not download it, because I can see right from the beginning that it would cost 3 months and 60,000 euros to download this data set. So there's self-describing information here, but separated from the data set itself. So we're adhering to F3 here, and these qualified links that get us through the F3. This is the I3. And I just maybe one more thing to really make sure it's clear. In the FAIR data point, there's a separation of the data and the metadata, and therefore the data sets that you link to could in principle be anywhere. And I think this is, at least from the GoFair point of view, this is a likely trend that we see or will see, that in the world of FAIR data and services, things probably become much more distributed. And so rather than having, say, a central repository where all the metadata is embedded somehow with the data set itself, or is there but not linked in some way, more and more using linked open data and semantic capabilities to adhere to the principles, it opens the door anyway to a much more distributed data ecosystem. So we could be linking from one FAIR data point to many possible repositories that are out there. In fact, you may house your data at multiple locations, but you could still link to those through the FAIR data point. Likewise, you could build FAIR data points that actually sit on top of other repositories or collections of repositories. So one way to make a repository FAIR is simply to expose some of that metadata in a FAIR data point configuration. And everything I've just said is also applicable to this idea of a FAIR digital object, But in that case, you're really building this fair digital object around individual data elements, if you think of them as digital objects. But this was, in any case, a reference implementation. It was a way to try and show an implementation of F3 and I3, 4 or 5 years ago now, 6 years ago. Here's an example of a real live fair data point that we set up over the summer at Kampala International University in Uganda. And this was run by a COVID pandemic project through the Phillips Foundation. And what you see here is a web client showing for a human user the metadata of a fair data point. So it's a repository. But behind this HTML is, of course, the RDF. So all of this is machine readable, machine actionable. But here you are at the highest level, the fair data point. So it's the Kampala International University fair data point. There's a description. There is some metadata, like when this was set up, when it was modified, a version, a language, a license, something about the institution, etc. So there's information here about the fair data point itself. And within the fair data point, there's one or many catalogs. In this case, there are 2 catalogs. There's COVID-19 case report forms and migrant media reports. And if I were to click on migrant media reports, then I go to this catalog layer. And again, you see a collection of machine actionable metadata, but there is a data set. In this case, there's only a single data set. But if you click on that data set, then you can see that there are distributions. And again, in this case, there's a single distribution. And this distribution is saying, hey, this is a Google document. So in and of itself, this Google document is not necessarily fair. It's just a document made for humans. And it's at a repository called Google Drive, which is just one of many possible places to store such a document. But if you click on the distribution, you will get to the online access to that. And if you click on that, you actually get to this Google document itself. So 2 things. One is that everything we just did as a human being could be replicated through a machine agent, because everything is written in this richly qualified RDF. And secondly, that this data set itself is not particularly fair. It's really a bunch of URLs on news reports of migration patterns due to COVID in Africa. But a machine would have very hard time dealing with this, but it's there for the humans. Simply by describing this file in a fair data point, we've made this Google document now much more fair. People can find it, people can understand what's in there, and it can lead to much more thorough data retrieval and reuse because of this rich metadata that's out there, but not embedded in this file. It's made searchable on the fair data point. I'm just showing here, this is my last slide. I'm just showing here what the, when you deploy these fair data points, they have a nice call home feature, and this allows us to keep track of these fair data points. Eventually, we imagine that you can come in and index all the details of these fair data points, or in a way, if you send out a Sparkle query, you can query all the details of these fair data points and do very targeted, very precise search and recovery of the data sets that you're interested in. So I hope that's a good foundation for the rest of today, because I think we're going to see a lot more current, recent, production level examples here. But I'll leave it there for now and say thank you. And if there's time, Andreas or Bert, I'm happy to take questions.
Thank you, Eric, for this very enlightening talk about making a split between the metadata and the data and why it's so important to comply with the F3 principle. I think we can take the questions after all presentations, so we still have 2 more presenters before we go to the questions and answers section, but now we